Hello. In a quadrilateral ABCD, we have AB, BC, and DC. These are displacement vectors, represent vectors P, Q, and R respectively. Expressed in terms of P, Q, and R, the vectors representing AC, AD, and DB. Now here is what the diagram looks like. We have A going to D, and yeah, that there, this there, that there. So we have AB, we have BC, and DC. So the direction is DC. So this is R, this is P, and this one is Q. Right, so we need to express in terms of P, Q, and R the vectors representing these displacements, A to C, A to D, and D to B. Now, if we look at the triangle A, B, C, so if you imagine there's a line here, then we have the triangle A, B, C. We have that AC, the displacement AC, so going this way, is the resultant of AB added to BC. So AB is going in this direction, BC is going in this direction, and our resultant is AC going into the opposite direction. So we have that AC, this displacement AC, and we can express it in terms of P add Q, the two vectors P add Q. So we have AC. Next, we look at the quadrilateral, we'll call it QUAD, A, B, C, D. Now we have that AD, so the vector, the displacement from A to D, this is equal to AB added to BC added to CD. Well, let's go a bit further and you'll see that CD, the displacement CD, is negative because it's going in the opposite direction to AB and BC. So we have that AD, the displacement AD, can express as P add Q, and we're going from C to D, which is going opposite to this direction of the vector R. So we have minus R. And then if we have a look at triangle BCD, it's BCD. So if we again put an imaginary broken line there, we have that DB, displacement D going to B, is equal to R. So we have R going in this direction. We have, in fact, let's not go straight to that. Let's just write the displacement vectors first. we have DC added to CB. So we're going in this direction from D to C and then C to B. And now we can write in terms of vectors DB. Now DC is R as we can see it, but CB is going the opposite direction to the vector Q, so it's minus Q. So there you have it. We've expressed AC here in terms of P and Q, AD in terms of P, Q and R, and finally DB in terms of R and Q. Again, this just makes use of two concepts: the concept of displacement vectors and determining the resultant vector, and using that to determine a way of expressing the displacement vectors in terms of the vectors P, Q and R. Thanks for watching. I'm Alistair.